Hello, Mrs. Butcher here, and this video is about inverse and joint variation. Okay, we have learned about direct and inverse variation in the past, and if you've forgotten, let me remind you. Direct variation is in the format of y equals some constant k times x, where k is not 0. Inverse variation is going to be in the format y equals some constant divided by x, where k and neither k nor x could be 0. And then joint variation is going to be the exact same thing as direct variation, but with more than one variable. So if I said y varies jointly with x and w and z, or whatever, it's all multiplied together. So jointly just means more than one. And as a side note, I think your textbook uses the letter A. I use the letter K. It doesn't really matter because it's not actually a variable, it's a constant. So whenever we're doing all these problems, we first have to figure out what that constant is. So here's an example. Tell whether x and y show direct variation, inverse variation, or neither. And the trick to answering these questions, whenever you see ones like this, is to first rework the problem so that y is by itself. So in this first one here, y over 9 equals x. In order to get y by itself, we need to multiply both sides by 9. Here, xy equals 3. In order to get y by itself, we need to divide both sides by x. And here, y minus 2 equals x. In order to get y by itself, we need to add 2 to the other side. So now that y is by itself, you know direct variation means constant times x, which is what we have here, kx. So this is direct. Inverse means constant divided by x, like this one, k over x. Remember, x would be your denominator, so that's inverse. And direct is k times, inverse is k divided by. We have not discussed anything with a plus, so this is neither. Okay, our next example says y varies inversely with x. So whenever you read that, immediately say y varies, so y equals, inversely with is constant divided by x. So we've got the setup. Then it says y equals 3 when x equals 6. So what we're going to do is plug those numbers in. 3 equals k over 6. So to find k, we multiply both sides by 6. 18 equals k. Write an equation that relates x and y. So when you see that and it says write an equation, that doesn't mean that one. That's close, but we actually need to know what k is for it to be a real equation. So when it says write an equation, you find out what the constant is, and then you say y equals, and then it's 18 over x. So that would be your equation. There. And then it says find y when x equals negative 9. So now we're just going to plug in 18 over negative 9, and you know that y equals negative 2. So these types of problems have two answers. Just like that. Alright, these types of problems say determine the type of variation the data shows, and they'll give you a table of data. So you have to figure out if it's direct or inverse. What you want to do is think, okay, when it's direct, we know that it's y equals a constant times x. So that means that our constant is equal to y divided by x. That means that if I have a bunch of data in a table and I take the y and I divide it by x, every time I should get the same answer. Alright, and then inverse is y equals k divided by x. So if I wanted to figure out what k was, I would multiply both sides by x. K equals x times y. So if I multiply x and y together, and they give us the same exact number every single time, the constant, then we know it's inverse variation. So when you're testing it, you're testing x times y and x divided by y. So if I said 5 times 45, I would have 225. If I said 10 times 22.5, I would have 225. If I had 15 times 15, I would have 225. If I had 20 times 11.25, 225. And 25 times 9 is also 225. So you can see that xy is constant here, and so because xy is constant, it is inverse variation. And your k is actually 225. You could write this y equals 225 over x. Because if I divided each of these x's, 225 by each of these, I would get these y values. All right, now look at the other table. If I did 1 times 6, I would get 6. If I did 2 times 12, I would not get 6. So I know it's not an xy constant, so let's try y over x. 6 divided by 1 is 6. 12 divided by 2 is 6. 18 divided by 3 is 6. 24 divided by 4 is 6. 30 divided by 5 is 6. So because y over x is constant, we know that this is direct variation. And your k is 6. Y equals 6x. 6 equals 6 times 1. 12 equals 6 times 2, and so on. So that's how you answer those questions. Okay, our next example. Z varies jointly with x and y. When you see the word jointly, immediately think directly. So z varies is z equals. Jointly would be a constant times. X and y just means times x times y. Okay, so z equals kxy will be the format of our equation. It says z equals 84, so I'm going to plug in an 84. When x equals negative 4 and y equals 3. Write an equation relating the variables. So first we need to figure out what k is, and then find z when x equals 5 and y equals 2. So this is 84 equals k times negative 12. And then we need to divide both sides by negative 12. Oh, problem was supposed to be negative 84. My bad. Just add a negative there, add a negative there, add a negative there. So if we divide negative 84 by negative 12, we get k equals 7. Alright, so that means when we write the equation, we're going to say z equals 7xy. That's the answer for writing the equation. A lot of people want to make this be the equation. No, that's where you start, but you have to actually figure out what k is. Alright, then it says find z when x equals 5 and y equals 2. And 7 times 5 times 2 is 70. The end. Okay, next example. Write a preliminary equation for the relationship. So that means just write it with k, but we're not actually going to solve for k. Alright, m varies, whatever. M varies jointly, so m equals, jointly is k times, np and q, so k times npq. M equals knpq. R varies inversely, so R equals k divided by S. X varies inversely with the cube of y. X varies, x equals, inversely, constant divided by, the cube of y means y cubed. So whenever you see these, don't leave off that little operation there. Alright, next one, z varies jointly, so z equals constant times x and y, x times y, and inversely, so we just put an divided by in the same problem with them. So when you see something that's direct and inverse, you just make it one equation. It's not two separate equations. Alright, and then the last one, t varies directly with u. T equals the constant times u, and inversely, so divided by w. And that's it. Alright, the last example I have for you today is a word problem. It says, Boyle's law states that for a constant temperature, the pressure P of a gas varies inversely with its volume V. A sample of oxygen gas has a volume of 50.25 cubic milliliters at a pressure of 20.6 atmospheres. Find the constant of variation, write an equation that relates P and V, and find the volume of the oxygen gas if the pressure changes to 15.2 atmospheres. Okay, so what we're going to do is, where it says the pressure varies inversely. So P equals K divided by the volume V. And then it says a volume of 50.25 cubic milliliters and pressure of 20.6. I'm going to plug those in. 20.6 equals K over 50.25. Multiply both sides by 50.25 and you get a constant of 1035.15. 1035.15. So write the equation. That would be P equals 1035.15 divided by the volume. There's your equation. It also says find the constant of variation. Oh, we did that. Okay. And find the volume if the pressure changes to 15.2. So now I'm going to plug a 15.2 in here for the pressure. Equals 1035.15 divided by the volume. So if I multiply both sides by the volume and then divide both sides by 15.2, I would have a volume of 68.102 cubic milliliters. And that's the three things they asked for, so we have answered the question. All right, you guys have a good night, and I will see you tomorrow.